Hello everyone and welcome to this tutorial. In this video, we shall go through Form 4 Mathematics revision, and these are the areas that we're going to cover. Statistics, loci, matrices and transformation, latitudes and longitudes, three-dimensional geometry, area approximation, application of differentiation and integration in kinematics, trigonometric curves, calculus, linear programming, and trigonometric equations. Question number 1 in section 1. The values given represent the ages of children checked at a health facility: 10, 12, 7, 8, 5, 6, 11, 9, and 10. Determine the semi-interquartile range of the data. You're determining the semi-interquartile range of the data. The first thing you're supposed to do is to identify which type of data is this. This is a group data. Then the next thing, how do you get the semi-interquartile range of this type of data and group data? That is where we should start. This is how we get it. So semi-interquartile range is obtained by getting half of the difference of Q3 and Q1, where Q3 represents the upper quartile, and then Q1 is the lower quartile. So how do we get Q1 and Q3? What you need to do is simply arranging this data in ascending or descending order. Either would work. So I'll do it in ascending order. So I arrange this set of data in ascending order. So from the smallest is a 5 to the largest. Then from 5 we have 6, 7, 8, and then we have 9. And then 10, can see there are 2, 10s are 2, and then from there we have 11 and 12. Confirm. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So after doing that, you need to divide this set of data into two halves. So I'll do that by first getting the median. The median here, you can easily identify the median. The middle value is here. That is Q2, the median. So you can see after identifying the median, we have two halves left. We have the lower half and we have the upper half. So this is the lower half, and then this one is the upper half. So now Q1 is the median of the lower half. The median of the lower half. So how do you get the median of the lower half? Look at this. To get the median of 5, 6, 7, and 8, you need to get the average of that. So Q1 will be given by the average of 6 and 7 divided by 2, and this will give 13 divided by 2, you get 6.5. So that is Q1. Then Q3 is the median of the upper half. So 10, 10, 11, and 12. So the median, you get the average of that, 10 plus 11. Then you divide by 2. This will give 21 divided by 2. And this will give 10.5. Now, after having that now, you can proceed and get the semi-interquartile range by simply getting a half. Then Q3, which is 10.5. minus Q1 6.5. This will give a half of this will be 4, and this will give 2. So that is how you're supposed to work it. Question 2. A curve is given as y is equals to 5x squared minus 19x plus 12. Determine the equation of the tangent and normal at x is equals to 1. So you have the function, it is given here. So there are two questions here, the equation of the tangent and the normal at x is equals to 1. So how do you go about that? the first thing we need to do is getting the gradient, because if you're getting the equation of the tangent is a line, is a straight line, and the normal is also a straight line. So to get the equation of a line, what do you need? You need the gradient and at least 1 point. So we first start by getting the gradient of this curve at this given point. And to do that, we shall begin by getting the gradient function that will assist us to get the gradient at x is equals to 1. So the gradient function will be obtained by differentiating the function with respect to x. So when you differentiate this function with respect to x, you get 10x subtract 19. So that is the gradient function, and that is what you're going to use to get the gradient at x is equals to 1. So at x is equals to 1, that is where the equation should pass. When you substitute there, you get 10 subtract 19, and this will give us negative 9. So that is the gradient of the tangent. Remember, if you do a rough sketch, if this is the curve, and here we have the straight line, so at this point is what you're given here is x. So this is the point you're given, x is equals to 1. So we want to get this point. Once we get that point, remember we have the x coordinate of that point and we have the gradient. We can denote this gradient as m1. The gradient of this straight line is the tangent. So that is negative 9. So now we have the gradient, we need 1 point, and we have the x coordinate of that point, so we need to get the y coordinate. So at x is equals to 1, what will be the value of y? We simply need to substitute x is equals to 1 in this function. So we have 5, then x is 1, so that will be 1 squared, subtract 19, x is 1, then plus 12. So this one will give y as, when you substitute that, you'll get this one as 5 subtract 19 plus 12. So this will give 17 minus 19, that will give negative 2. So now we have the point where that tangent will pass. So x is equals to 1, y is equals to negative 2. So the point therefore will be, when x is 1, y is negative 2. So that is the point where the tangent is going to pass. So it is actually this point that you can see here. And then you have the gradient. The gradient is negative 9. So if we have 1 point in the gradient, we can get the equation. So you simply take 1 and negative 2 and introduce another general point on that line xy, and you calculate the gradient using these 2 points, 1, negative 2, and x, y. So gradient is given by change in y, which is y subtract negative 2, that will be y plus 2, divided by change in x, x subtract 1, and that one should give negative 9. The gradient. So you cross multiply, so you get y plus 2 is equals to negative 9x plus 9. So this will give y is equals to negative 9x, then plus 7. So that is the equation of the tangent. So this is the equation of the tangent. Now let's go to the normal. The equation of the normal. So one thing you need to understand is that the normal is perpendicular to the tangent. The normal is perpendicular to the tangent. And since we know the relationship between two lines that are perpendicular in terms of the gradient, that will help us to get the gradient. So if we have the gradient of the tangent as negative 9, so the gradient here is negative 9. So what will be the gradient of the normal? It will be 1 divided by 9. Why? because given two lines that are perpendicular to one another, I'll say the first line has gradient as m1 and the second line has gradient as m2. When you get the product of the gradients of two lines that are perpendicular, you should get -1. So now we have the gradient of the normal as 1/9. If you multiply 1/9 times -9, you get -1. And we have the point. We have the point where this normal is passing. It is still the same point at x is equals to 1. And we got that point, the y coordinate. So therefore, we should be getting the equation of line passing through 1, -2, and having the gradient of 1/9. So we simply introduce another general point on that line, xy, and use these 2 points to calculate the gradient, which is 1/9. So gradient is given as change in y subtract -2, which is y plus 2, divided by change in x subtract 1 is equals to the gradient of the normal, 1/9. So if you cross multiply here, you get 9 multiplied by plus 2 is equals to x minus 1. And this will give 9y plus 18 is equals to x minus 1. So 9y is equals to x minus 1 subtract 18, which will give y is 1/9x. And then this will give -19 divided by 9. So that is the equation of the normal. So we have identified the equation of the tangent is there. The equation of the normal is there. Question 3. A surveyor followed a route PQRSTUVW when taking the measurements of an irregular piece of land. She represented the land on a map using the scale 1:. This is 500,000. This is 500,000. Find the area of the piece of land in square meters. The area of the piece of land in square meters. And then you're given the scale here. So let me begin from the scale. The scale is 1:500,000. So that means 1 centimeter on the map represents 500,000 centimeters on the ground. So since you're required to give the area in meters, in square meters, you can convert this scale to meters. So 1 centimeter will represent, so convert 500,000 centimeters to meters by dividing by 100. So this will be 5,000 meters. We require the area, so we can square 1 centimeter squared, can square that, and when you square these, you'll get 1 centimeter. When you square, you get 1 centimeter squared represents 500, this 5,000 meters squared. When you square that, you get 25 million meters squared when you square that. So this is the scale that you're going to use when we calculate the area. We shall use this one to convert. Now let's go to calculation of the area. How do we get the area of this irregular shape piece of land? We start by getting the full squares. So we get the full squares, and then we get the half. We get the half squares. So full squares are the ones that are exactly full. Let me count them. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So those are the ones that are full. Make sure you're very careful. So they're 17. Then the half squares are the ones that are not full. However small a square has been touched, we take that as half square. However small it has been touched. So let me begin from here. So we have this one, we have 2, 3, then there is this one here that has been touched. So this one is another square here, so that one is another square, it has been touched, you can see that. So 1, 2, 3, then you have this square 4, then you have, I'm marking outside, slit outside, because there's a very small part of that square that has been touched. 1, 2, 3, 4, 5, 6, 7, then you have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, then 26, and then there is a 27, 27, 28, and finally we have 29. So half squares are 29. So how do you get the area? Now the area is obtained by getting the full squares plus, then the half squares, we divide that by 2. So this will give 17 plus, this will be 14.5, and this will give 31.5 centimeters squared. So that is the area in centimeters squared. Now we need to convert. We come to this side. So 1 centimeter squared represents 25 million meters squared. So what about that 1.5 centimeters squared? So we need to multiply that 1.5 multiply by 25 million mean, and this will give, so we have that 1.5 times 25 million, that will give 787,500,000 meters squared. Question 4. Evaluate. You're supposed to integrate 3x cubed minus 4x squared plus 2 with respect to x from 3 to 5. Before you integrate, you need to understand the basics. So remember, when you're integrating, you need to remember how you integrate. Given, you need to recall this, given ax raised to power n, to integrate that one, you get ax, then you add the power, you add 1 to the power, then you divide by n plus 1. So this is what you're going to use. Ensure that you've gone through the basics on how to integrate. Now let us integrate what we have here. We integrate each term at a time. We start with 3x squared, 3x cubed. So integrate 3x cubed, you get 3x raised to power 4 divided by 4. Then when you integrate 4x squared, that will give 4x cubed divided by 3. When you integrate the constant 2 with respect to x, you get 2x. Then you have to add by integrating the constant of integration. Put the square brackets. Then the range is from 3 to 5. Once you've done that, now you need to substitute x. Start by substituting x with 5. Substitute x with 5 here. So that you have 3 over 4. X is x raised to power 4. So that will be 5 raised to power 4. Subtract 4 that. X cubed. So that is 5 cubed. Then plus 2x to multiply by x is 5. You're substituting 5. You can drop the constant of integration at that point, because whenever you proceed with it, it will be subtracted and you'll get 0. Now substitute 3. So 3 quarters, x raised to power 4, that is 3 raised to power 4. Subtract 4 thirds. X is cubed, so that will be 3 cubed. Then plus 2, x is 3, like that. you use a calculator from this stage. So 3/4 multiplied by 5 raised to the power 4, that will give 1875 divided by 4. Then 4 thirds multiplied by 5 cubed, that will give 500 over 3. Then this will give 10. The other one, 3/4 multiplied by 3 raised to the power 4, give 243 divided by 4. Subtract 4 thirds multiplied by 3 cubed, that will give 36. Then plus 6. You can work out everything here. 1875 divided by 4, subtract 500 over 3 plus 10. Using a calculator, that will give 3745 divided by 12. Then for this part, 243 divided by 4, subtract 36 plus 6. That will give 123 divided by 4. So once you subtract these, 3745 divided by 12, subtract 123 divided by 4, that will give, subtract these, that will give 281 and a third. So that is the final solution. Question 5. Use the mid-ordinate rule to estimate the area bounded by the curve y is equals to x squared minus 9, the x-axis, and the lines x is equals to 2 and x is equals to 5 using 6 strips. So the first thing you're going to do is to get the interval. Get the interval that you're going to use in order to have the 6 strips, and this is how we get the interval, which is the height. So the interval is given by, so the height is given by this range you're given, x to 2 to x is equals to 5. So you take 5, subtract 2, then divide by the number of strips, and this will give you the interval of 0.5. So that means we shall use this interval from 2 to 2.5, then from 2.5 to 3 to 3.5, then to 4, then 4.5, and then 5. That is the interval you're going to use. Now, using the mid-ordinate rule, we shall get the midpoints of each of the strips. So for example, the first one, from 2 to 2.5, the midpoint there, we shall take 2.25. The next one, between 2.5 and 3, the midpoint there will be 2.75. From 3 to 3.5, the midpoint will be 3.25. Between 3.5 and 4, that will be 3.75. That is the midpoint. From 4 to 4.5, the midpoint will be 4.25. Then from 4.5 to 5, you get 4.75. So those are the midpoints that you're going to use when you are getting the ordinates. So now after doing that, we need now to get the heights. We need to get the heights. So those are the ordinates that you're going to use. The mid ordinates. That is the midpoints of each of those strips. So now we're going to fill this table here in order to have the ordinates. So we have y, and then we have x. Sorry, this is x. And then for y, to get y, we shall use that function, x squared, subtract 9. So you simply substitute x in that function, y is equals to x squared. For example, the first one, y is equals to x squared when x is 2.25. Just substitute there and fill this one using a calculator. So when you use a calculator to fill these are the values that you're supposed to get. The first one will be negative 3.9375. This will be 9375. So 9375. Then for 2.75, that will give you negative 1.4375. 3.25 will give 1.5625. Then the next one will 5.0625. Then the next one is 9.0625 and 13.5625. So those are the heights. Now using the mid-ordinate rule, how do you estimate the area? Area using the mid-ordinate rule is given by height, then multiply by the sum of the ordinates. The sum of the ordinates. The height is 0.5. Now we add the ordinates. Now for the negatives, we're going to ignore the negatives. -3. The first two you can see they are negative. That means when you see they are negatives, it means there is an area that lies below the axis. When you sketch this curve, you'll notice there is a part of that area between 2 and 3. Have the interval from 2 to 5. So from around 2 to 3, you'll find that that area lies below the x-axis. That is why it is negative. Since when you're getting the area, we use the ordinate. The ordinates are the heights. We can't have the negative y, so we ignore the negative. We take the absolute values, that is the positive values only. So ignore the negative. We take 3.9375 plus 1.4375 plus 1.5625 plus 5.0625 plus 9.0625 plus 13.5625. So this will give, we add this one. So 3.9375 plus 1.4375 plus 1.5625 plus 5.0625 plus 9.0625 plus 13.5625. So that gives 34.625. 34.625. And when you multiply that one by 0.5, you get 17.3125 square units. Question 6. So for x in the equation, √3 tan of 2x minus 20 is equals to -1 for the range x is greater than or equal to 0 and less than or equal to 360. So to solve this question, I remember we're solving for x, so we need to eliminate everything from the left hand side and remain with x. Simple terms, we need to make x the subject in order to get the value of x. So therefore, we'll begin by dividing both sides of this equation by √3. So when you divide both sides of this equation by √3, the left hand side, you'll be left with tan of 2x subtract 20 degrees is equals to -1 divided by the √3. Then the next step, we want to eliminate the tangent on the left hand side. So we get the tan inverse from both sides. Obtain the tan inverse from both sides. When we obtain the tan inverse from the left hand side, we remain with 2x subtract 20. Then we get the tan inverse of -1 divided by √3. So this will give 2x subtract 20 is equals to tan inverse of -1 divided by √3. Now the first thing that I would like to clarify, when you're getting the tan inverse, you are going to ignore the negative sign. So I'll remove the negative sign here, this stage. So simply get the tan inverse of positive 1 divided by root of 3. Why have I ignored the negative? The negative is simply there to show us where we are going to obtain the angles. So let me draw the unit circle to explain. We have the 4 quadrants, and in the 4 quadrants, that negative implies we are going to get the angles in the quadrants where tangent is negative. And these are the third, actually the second quadrant and the 4th quadrant. So these are the 2 quadrants where we shall obtain our angles. So that is the meaning of the negative sign there. Otherwise, when you're getting the tan inverse, ignore the negative. Get the tan inverse of positive 1 over root 3. So when you get that, it will give you tan inverse of 1 over root 3. That will give 30 degrees. So 30 degrees is what you're going to use to get the other angles. So the angles are in the 2nd and the 4th quadrant. So let's go to the 2nd quadrant. So the 2nd quadrant, we get the angle by getting 180 subtract 30, so it will be 150 degrees. That is the angle in the 2nd quadrant. So now getting the value of x using that, so we have 2x subtract 20 is equals to 150. So here we shall have x as x will be 85 degrees. That is the first solution. Then in the other quadrant, now in the fourth quadrant, so the fourth quadrant, the angle, we get it by 360 subtract 30, so the angle will be 330 degrees. Now we use that angle to get the value of x, so 2x subtract 20 degrees is equals to 330, and for this one, x will be given by 350 divided by 2, you'll get 175. So 2x subtract 20 is equals to 330, so x will be 175. So that is all. So when I look at the range is between 0 and 360, so it means we can try to go the second round, see whether we can get other angles. So now the second round, second quadrant. So the second quadrant, the angle, we are going to get it by, so in the second round, remember the second quadrant will be 540 subtract 30 degrees, so the angle there will be 510 degrees. So now we use equation here, so 2x subtract 20 degrees is equals to 510. So here x will be 265. So you can see it is still within the range, 265. So now we can go to the fourth quadrant. Now in the second round, the fourth quadrant, now the angle would be 720. The angle that will be there will be 720 subtract 30. So this will be 690. So now getting the angle, 2x subtract 20 degrees is equals to 690. So here x will be given by, it will be 710 divided by 2. So this will be 335. So it will be 697. Let me divide these. So let me confirm something here. So this is 710. So 690. So it will be 710 divided by, so this will be 355 degrees. So you can see that one being the last one, 355. That means if we proceed to the next round, probably we're going to exceed the range 0 to 360. So therefore, the angles that we require are, so the angles, that is the value of x, will be, the first one you got was 85 degrees. Then second one was 175. Then 265 and 355. Question 7. By transformation, an object of area x centimeters squared is mapped onto an image whose area is 13. Something is missing here, the typo error. This one is supposed to be 13 x centimeters squared. Get note of that. So by transformation, an object of area x centimeters squared is mapped onto an image whose area is 13x centimeters squared. Given that the matrix of transformation is given there, find the possible values of x. So to solve this question, you require to have the concept, since you have the matrix of transformation, that area scale factor is equivalent to the determinant of the matrix of transformation. You can see you have the area of the object and you have the area of the image. That will give us the area scale factor. So area scale factor is the area of the image, which is 13x centimeters squared, and then the area of the object is x centimeters squared. So you notice that these will give 13. So the area scale factor is equals to 13, and therefore 13 is also the determinant. Having known that, we can use these matrix here to find the determinant. So find the determinant of this matrix. So you know how to get the determinant. So x multiplied by 3x. So you're getting the determinant. So x multiplied by 3x. Then subtract 7 multiplied by x subtract 1. So this will give 3x squared subtract 3x plus 1. This is plus 7. So that is how you get the determinant. And remember, the determinant is equivalent to area scale factor, which is 13. So that is what you have. Now when you look at this, you notice that you can reorganize it to form a quadratic equation. So I'll reorganize this. So you'll have 3x squared subtract 7x. Then this one you can take 13 to the right hand side, and this will give negative 6 is equals to 0. So you can see you've ended up having a quadratic equation, and when you solve this quadratic equation, you get two values of x, and that is what is going to give you the solution. So we solve this quadratic equation. So you can use any suitable method, quadratic formula or factorization. So I'll use factorization to solve these. So 3x squared minus 7x minus 6, using factorization, I will have 3x squared. Remember, I'm finding two numbers whose product is going to give negative 18, and sum will give negative 7. So which are those two numbers? The two numbers are negative 9 and 2. Negative 9 and 2. So 3x squared negative 9x plus 2x subtract 6 is equals to 0. Factorize this. 3x is common. So we have x subtract 3 plus 2. and then this is x subtract 3 is equals to 0. So you have 3x plus 2, x subtract 3 is equals to 0. Now you can give the solution. So 3x plus 2 is equals to 0. So the first value of x will be negative 2/3, or x subtract 3 is equals to 0, x will be 3. So those are the two possible values of x. Question 8. A plane left point A 45 degrees north, 10 degrees east to another point B along the parallel of latitude. When the local time at A is 3:30 p.m., that of B is 11:30 a.m., find the position of B. Find the position of B. So since point A, point B is along the same parallel of latitude. When you look at this statement, a plane left A to another B along the parallel of latitude. So that means that A and B are on the same latitude. So A is 45 degrees north, 10 degrees east, and then it is moved to B. B will be on the same 45 degrees north, but now we don't know the longitude. What is going to help us is the time difference. You can see when the local time at A is 3:30 p.m., B is 11:30 a.m. So that time difference is going to help us to calculate the longitude difference. So let's get the time difference. So the time difference, which will help us get the longitude difference. So 3:30 p.m. is the same as 15:30 hours, 24-hour clock system. Then you subtract 11:30 a.m., that is 11:30 hours. So the time difference between the two is exactly 4 hours. Using the time difference, we'll be able now to calculate the longitude difference. Why? Because we know that 1 degree has a difference of actually 1 hour. We use this one. This is the easiest one. You can use 1 degree as a difference of 4 minutes, or 1 hour, a difference of 15 degrees. So I'll use this one. 1 hour is equals to 15 degrees. So what about 4 hours? What degree difference will 4 hours give? So you just multiply 4 multiplied by 15. That will give 60 degrees. So 60 degrees, therefore, this is the longitude difference between the two places A and B. That will be the longitude difference. Now, using the longitude difference, since we already have the longitude of A, which is 10 degrees, and when you look at the two places, you can see the one that is ahead of time. A is ahead of time. So if A is ahead of time, then it means B will be behind time. That, you know, that places that are to the east of the prime meridian are always ahead of time. Places that are to the west are behind. So in this case, A will be more to the east, then B will be to the west because it is behind of time. So therefore, to get the longitude difference, the longitude of B will be given by the longitude of B. You simply take the longitude difference, then subtract the longitude of A. Since it will be behind time, that will be 50 degrees. 50 degrees. And this will be to the west. Just say that is because it is behind time. So it will be 50 degrees to the west. So this is 50 degrees west. So that is the position of B. Supposed to be written like this. Latitude, then the longitude. Question 9. Triangle ABC has vertices A, -3, 1, B, -3, 4, and C, -1, 4. M and N are transformations represented by matrix 0, negative 1, that is m, 1, 0, and n, 1, 0, 2, 1. Find the coordinates of the image A double prime, B double prime, C double prime from formed by ABC undergoing transformation n followed by m. One thing that I would like you to notice here is successive transformation. Successive transformation. Successive transformation is here. N followed by m. How do we write that? N followed by m will be written as mn. That is n followed by m. That is how we write successive transformation. And therefore, we need to have this multiplication. So we have matrix M, which is 0, negative 1, 1, 0, multiplied by n, which is 1, 0, 2, 1. And then we have that product. I'm sure you know how to multiply the matrices. So this one you get when you multiply 0, 0. So this one will give 0. Then row 1, column 2 will give 1. You get 1. Then row 2, column 1, this will give negative 1. And then the one will give negative 2. So that is the single matrix of a successive transformation. This is n followed by m. After doing that, we now need to pre-multiply this one with the object, that is triangle ABC. So we have that matrix 0, negative 1, 1, negative 2. We multiply this by A, B, C. In order to get A double prime, B double prime, C double prime. So this is negative 3, 1. For B, negative 3, 4. C, negative 1, 4. So when you multiply these, so this will give 1. So row 1, column 2, this will give 4. This will give 4. Then the second one will give, this is 3 minus 2. This will give 1. Then we have 3 subtract 8. This is negative 5. And then we have 1 subtract 8, negative 7. So that is what you get when you multiply. Now you're required to give the coordinate. The coordinates will be given as A double prime, that is a 1, 1, B double prime, 4, negative 5, C double prime, 4, negative 7. Question 10. The mean of 6 numbers is calculated. The deviations of the numbers from the mean are 3, 1, y, 5, negative 4, and negative 2. Determine the value of y and hence find the standard deviation of the numbers. So you're given the deviations of the numbers from the mean. Here they're given as, so those are the deviations. So let me write them here. So the deviations from the mean are, we have 3. So 3, 1, we have y, 5, negative 4, negative 2. So those are the deviations from the mean. So the deviations are given there. So you're required to find the value of y. You don't have 1 here. So what are you supposed to know? One thing that will help you is this concept that the sum of the deviations from the mean is equivalent to 0. When you add all these deviations, they're supposed to give you 0. Now let's add them. So you have y plus 5 plus negative 4 plus -2 plus 3 plus 1. This one should give 0. So this will give y 5 plus -4 plus -2 plus 3 plus 1. This will give you +3 is equals to 0, and therefore y will be -3. So already now we have y as -3. So that is the first thing. The second question, find the standard deviation of the numbers. So how do you find the standard deviation? This one is a group data, simple data. So to find the standard deviation, it will be given by the square root of the variance. And the variance, you get the variance by the sum of the deviation squared divided by n. N is the total number of values. There are 6 values here. 3, 1, or those are 6. So we need to get the deviation squared. So we square all these deviations. So we shall have the first one is 3 squared, 9. This is a 2. -3 squared is 9. We have 25. We have this is 16. The other one is 4. You square the deviations. So once you square the deviations, you get the sum. You add. What is the sum of the deviation squared? So you add 9 plus 2 plus 9 plus 25 plus 16 plus 4. These will give 64. So you get 64 divided by, there are 6. So you divide by 6 and then you get the square root. So when you work out these, 64, that is the square root of 64 divided by 6. These will give 3.266. So that is how we find the value of y and the standard deviation. Question 11. Two towns on the Earth's surface are located at P 17 degrees north, 30 degrees west, and Q 13 degrees south, 30 degrees west. A pilot plans to fly from P to Q. Find the distance in nautical miles. 3 marks. So the first thing is to identify which type of distance is here. This is a distance along the great circle. You can see these two places, P and Q, are located on the same longitude. They are located on the same longitude, as you can see, but on different latitudes. One is to the north, the other one is to the south. So these two places are distance along the great circle. So how do we get the distance along the great circle in nautical miles? So distance is given by 60 multiplied by the latitude difference. So theta is the latitude. So theta is the latitude difference. So therefore, this will be 60 multiplied by the latitude difference. You can see you have 17 degrees north and 13 degrees south. So to get the latitude difference, you simply add. So you have 17 plus 13. So this will give 60 multiplied by 30. This will give 1800 nautical miles. Question 12. State the period and the amplitude of y is equals to sine 3x plus 30. How do you identify in a given equation the amplitude and the period? Now recall these. Given general function that y is equals to a sine of bx plus or minus theta, or maybe it could be y is equals to a cosine of bx plus or minus theta, then a, that is the absolute of a, is the amplitude of that curve. And then the period will be given by 360 divided by the absolute of b. So this is the period. And then, though this one is not required here, the phase angle again is the absolute of theta. Absolute means that you only consider the positive values and ignore the negative, only the positive values. So in this particular question, when you compare these, the period will be given by, the period will be 360 divided by b, in this case is 3, so it will be 120. Then the amplitude is 1. When you just look at the coefficient of sine is 1. Question 13. The equation of a curve is y is equals to negative 3x squared minus x cubed. Determine its stationary points and their nature. So there are two questions here. One is determining the stationary points, and the second one is determining their nature. So one thing that we need to understand before solving this question is that at stationary points of a curve, so at stationary points, the gradient is equivalent to 0. So we need to get the gradient function, and we differentiate this function with respect to x. So dy dx therefore is equals to, this will be negative, when you differentiate negative 3x squared, we get negative 6x. When you differentiate x cubed, we get, this will be negative 3x squared. So that is the gradient function. And you say that at stationary point, the gradient function will be 0. Remember, this is what is going to give the gradient. This is a gradient function, and you're going to equate this one to 0 at stationary point. So we have negative 6x minus 3x squared is equals to 0. So you find the x values at which the gradient will be 0. This is the x coordinate. So this will give, we can factor out what is common here. Negative 3x is common. So we have 2, then plus, this will be x is equals to 0 when you factor out. So that is okay. Confirming. So we have two values of x at stationary point. So this is a negative 3x is equals to 0. So the first one will be x is equals to 0, or 2 plus x is equals to 0. So this will be, x will be negative 2. So these are the two values of x at which the gradient will be 0. So these are the x coordinates of the stationary points. Now what we need to get is now the corresponding y values. The corresponding y values. So when x is equals to 0, what is the corresponding y value for us to get that point? So use this function. Y is equals to negative 3x squared minus x cubed. Substitute when x is 0. So y will be 0. So therefore the first stationary point is 0, 0. Then the second one, when x is equals to negative 2, what will be y? You simply need to substitute. So negative 3, so negative 2 squared minus negative 2 cubed. So this will give negative 4. So this will give negative 4. So when x is negative 2, y is negative 4. So the point, the other stationary point, therefore will be negative 2, negative 4. So these are the two stationary points, 0, 0 and negative 2, negative 4. Now the next question is now determining their nature, whether maximum, minimum, or point of inflection. So to do that, we are going to use the second derivative. So we get the second derivative. So the first derivative is negative 6x minus 3x squared. So the second derivative, when you differentiate this one for the second time, you get negative 6 minus 6x. that is the second derivative. So this is how we test the nature. If we find that the second derivative, note this, that if you find the second derivative is greater than 0, then that one will be a minimum point. If you find that the second derivative is less than 0, that is maximum point. And if you find this is 0, that means it is a point of inflection. So let us test. So let me read the other one. So if it is 0, that is a point of inflection. So we can test with the first one. When x is 0, the first stationary point is 0, 0. So we are testing with x is equal to 0. You simply substitute it here in negative 6. Negative 6, negative 6x. So that one will give negative 6. So the second derivative will give negative 6 when you substitute x is equal to 0 in the second derivative, that is negative 6 minus 6x. So you can see this one is less than 0. So that means that 0, 0 is a maximum point. Then you test the second one. The second stationary point is negative 2, negative 4. So we test with the x coordinate. X is negative 2. Just substitute in the second derivative, negative 6, subtract 6x. So this will give negative 6, subtract, this will give plus, is it 24? It will give 24. And so this will give positive, this will give positive 18. So if it is the second derivative is giving positive 18, so that means it is greater than 0. So this will be a minimum point. So that means that negative 2, negative 4 is a minimum point. So we have identified the stationary points and we have determined their nature. Question 14. The gradient function of a curve is given as 3x squared plus 12x minus 15. The curve passes through the point P, negative 1, 4. Determine the equation of the curve. Now, given the gradient function of the curve, we get the equation of the curve by simply integrating the gradient function. That is 12x subtract 15. So you get the equation by simply integrating this function. So integrate 3x squared, you get 3x cubed divided by 3. Integrate 12x, you get 12x squared divided by 2. Integrate 15, you get 15x. Then don't forget to add the constant of integration. Simplify these, you get this as x cubed plus 6x squared subtract 15x plus c. Now what we need to get is the constant of integration, and this point that you're given here, p negative 1, 4, is what is going to help us. So we simply substitute x as negative 1 and y as 4 in this function here. So y, which is 4, substituting negative 1 and 4 in that equation. X is negative 1 cubed plus 6. X is negative 1, like that, then plus the constant integration. So this will give 4 is equals to, this is negative 1 plus 6 plus 15 plus c. So C therefore be given by, so this is a 21, subtract 1, that is let me see these. So 21 subtract 1, that is 20. 4 minus 20, that will be negative 16. That will give negative 16. So constant of integration is negative 16. Now we can get the function. So y is equals to x cubed plus 6x squared subtract 15x, then plus the constant of integration is negative 16. So that is the equation of the curve. Question 15. Part A. Using a ruler and a pair of compasses only, construct triangle ABC such that AB is equals to 6 centimeters, BC is equals to 5.5 centimeters, and angle ABC is equals to 60 degrees. Then part B. Draw a locus of points equidistant from side CB and AB. So let's go to the first part. So using a pair of compasses and the ruler only, triangle ABC. So start by drawing the baseline as AB. So the baseline is AB. So we draw that. So the baseline to be AB, and that one should be how many centimeters? AB 6 centimeters. So place point there. So this will be point A. So this will be point A. So now we get measurement of 6 centimeters. So from that point we have that is 6. So I'll need to mark that point there. That would be 6. So 6 is that point. So this is a point B. So that is 6 centimeters. Then angle ABC is 60. So you need to construct 60 at B. So to construct 60, you stand at B. Then any suitable radius of your choice. So you mark. So any suitable radius, you mark down. You can mark a bigger one like that. And then with the same radius, they're changing it, stand at this point. And then cut that arc. Need to have made a big arc. So I'll go back to that point. So see, so that is a point. So I need to extend that arc. So that is the arc. So with that radius, so I have to repeat this. Then you stand here. Then you cut that arc. Then you join B. Like that. You need to be very careful using a straight line, the point of intersection of the arcs. So these will be 60 degrees. That will be 60 degrees. Then AB is equals to 6 centimeters. Then BC should be 5.5. So what I need to do, You need to take a pair of compasses, then go to the ruler, then take that measurement of 5.5. 5.5 is there. So with measurement of 5.5, standard B, and then cut that arc. So this is point C. That is point C. Now you can complete the triangle by joining A to the point of intersection of, that is why we have C. So the triangle is complete, it's there. So this is a 5.5 centimeters. So that is the first part. So we've constructed the triangle ABC is there. So the second question, part B, is draw the locus of point equidistance from sides CB and AB. So which type of locus is this? Equidistance from two given sides, CB and AB. That is the angle bisector loci. So we need to bisect the angle between those two lines, that is CB and AB. That is the locus, that is what will give the locus of point equidistance from two given sides, the angle bisector loci. So we bisect that angle between BC and BA or AB. And since I've already made the axiom, so you need simply to stand at this point and you mark arcs. So I'll use the arcs that I made there. So you mark and you stand at B to bisect the angle between AB and BC. You mark an arc there and another one there. So I'll use the arcs that are already there. Then standing on this arc here, this point here, then you can adjust using any suitable radius. So you can draw an arc there, bigger one, then with the same radius without changing that. Stand at this point, here, then cut that arc. So now the angle bisector loci will be, you join B 2 point, the section of those arcs. So that is the locus of point equidistance from side CB and AB, that angle bisector line that I've drawn there. That is how you're supposed to solve that part. Question 16. Mr. Dhiombo had 20,000 shillings available and decided to purchase some Kiswahili and CRE textbooks. A Kiswahili textbook and a CRE textbook costs 350 and 400 shillings respectively. He has to buy at least 26 Kiswahili textbooks, and twice the number of CRE textbooks bought must be greater than the number of Kiswahili textbooks. Taking the number of Kiswahili and CRE textbooks to be X and Y respectively, write down three inequalities satisfying the conditions in the information above. So after reading carefully, you're supposed to come up with three inequalities satisfying those conditions, and you have to let the number of, so let the number of given here, so number of Kiswahili books to be represented by X, and then CRE books to be represented by Y. So you go to the first statement. So he has 20,000 available, and a Kiswahili textbook costs 350. So what about X Kiswahili books? If one Kiswahili textbook costs 350, So X Kiswahili textbooks will cost 350 X shillings, plus CRE book costs 400. So what about Y Kiswahili books? CRE books to be 400 multiplied by Y. So now that represents the amount of money required for X number of Kiswahili books and Y number of CRE books. And that amount, because you're given that Odhiambo has 20,000 shillings available, that means this total amount should be less than or equal to 20,000, because that is the amount available to purchase CRE books, that is X number of CRE books, and X number of Kiswahili books and Y number of CRE books. So that is the first inequality. The second one, he has to purchase at least 26 Kiswahili books. At least means what? It means greater than or equal to. So Kiswahili books X should be greater than at least 26, means greater than or equal to 26. That is the second one. Then and twice the number of CRE books bought must be greater than, so twice CRE books, number of CRE books, so it be 2 times number of CRE books is Y. It must be greater than, must be greater than, not greater than or equal, but just greater than the number of Kiswahili textbooks, which is X. So that is another inequality, or you can write it as X should be less than to Y. It is still the same thing. So these are the 3 required inequalities that you're required to come up with. Section 2, question number 17. The table below shows the distribution of marks scored by 100 candidates by Cheptiret boys in an exam. So the marks are there, the frequency is given there. The first question, draw a cumulative frequency curve to represent the information. Draw the cumulative frequency curve, also known as the Ogive curve, to represent the information. Let's go to the other question down there. Using the graph, find 1, the median, 2, the semi-interquartile range, then 3, the pass mark if 70% of the students passed. So those are the questions. So let's go to the process of drawing the cumulative frequency curve. So what do you need to draw the cumulative frequency curve? You need the upper class boundaries of those classes given, and then you need the cumulative frequency. That is the first thing. You plot the cumulative frequency against the class boundaries. So that is what you're going to do. So we jump straight. I've drawn these. I'm going to explain how you're supposed to draw these step by step. So we have the first thing, and you're required to get the class boundary, the upper class boundaries of each of those classes. So for the first class, we have it goes from 11 to 20. So the upper class boundary is 20.5. The second one is 30.5. The other one 40.5, 50.5, 60.5, 70.5, 80.5, 90.5, 100.5. That is what is supposed to come to the x-axis, the marks, the upper class boundaries of the marks. So you can see the first class begins from 11. So when you're drawing your cumulative frequency curve, you can start slightly below that. That is why I've started from 10.5, and then I've used the scale of 1 centimeter to represent 10 marks. Only that from 0 to 10.5 for this particular square here, the scale is not uniform. So otherwise from 10.5 going all the way to 100.5, the scale is uniform. It is 1 centimeter represents 10. So that is why I've broken this part to show that the scale at this square is not uniform with the others. So that is what you're supposed to do, the first thing. Then when it comes to the y-axis, you need the cumulative frequency. So you know how to get these. So the first one is 7. So you add 7 plus 8, you get 15. 15 plus 19, 34. 34 plus 24, 58. 58 plus 18, 76. 76 plus 10, 86. 86 plus 6 is 92. 92 plus 5, you get 97. 97 plus 3, 100. So this is a cumulative frequency, and it should come with the y-axis. So the scale, look at the smooth. You have 0 to 100. So I've used 1 centimeter to represent 10, 10, 20, 30, all the way to 100. So now you have the upper class boundary representing the marks, and then you have the y-axis where you have the number of students. You've used cumulative frequency. So now you plot. You have the first one is 20.5, 20.57, 7 is there. Then 30.5 is here, 15, 15 is there. 40.5, 40.5, 34, 34 is there. Then 50.5, 50.5 you have 58, 58 is there. Then the next one is 60.5, 76, 76 is there. Need to be very keen when you're plotting. Then 70.5 you have 86, 86 is here. And then you go to 80.5, 80.5, 92, 92 is here. So one small square represents 2 in both axes. One small square represents 2. Then 90.5, 97, and then 100.5 is 100. So after doing that, join those points using a smooth curve. Join from this point, you join point using a smooth curve like that. Ensure that your curve is smooth. Then since it is beginning from 20.5, don't leave your ogive hanging. Make sure you anchor it to the x-axis by joining these from this 20.5, this point you join to the x-axis. Don't leave it hanging like that. So that is how you draw it, and you're done for that part. So you've drawn the cumulative frequency curve. Let's go to the questions now. Go to the questions. Using the graph, find the median. Find the median. So how do you find the median? The median is the middle value. So the median position would be located at, so total frequency is 100. So the position will be of the median will be half of that total frequency. So it will be located on the 50th position. The 50th student will give the median, the 50th student. So what do you need to do? You go to your graph and go to the graph where you have 50. The 50th student is 50th. So you draw a straight line direct to up to where it touches the curve, then you drop down. So that is what I'm going to do. So from 50, so draw a straight line like that. Straight line up to where it touches the curve. So you can see it touches the curve at this point. Let me draw this one again. That is the thing. So then from here, from this point, you drop down. You drop down like that. So you can see you've drawn a straight line from 50th student up to where it touches the curve. Then you drop straight down, straight down. So this is the value that you're going to read here. This is what is going to give you the median. So you read this value. Remember the scale. 1 centimeter represents 10. So one small square represents 2. So this is a 42.5, 44.5, 46.5. So that is a 46.5. So 46.5. That is the median mark. That is the median mark. Then the next one is part 2, the semi-interquartile range. So how do you get the semi-interquartile range? Semi-interquartile range is given by, so semi-interquartile range is given by a half of the difference of the quartiles, whereby Q3 will be 3/4 the position. You're going to get the position by taking 3/4 times the total frequency. Total frequency is 100. So the 75th student will give the upper quartile. Then the lower quartile is a quarter, is 100. This will be the 25th student. So to get Q3, go to the 75th student from the graph, the 75th student from the graph. So 75th student. So draw straight line. So 75 is exactly between 70 and 80. So I need to be very keen here. So 75 is there. That way. So that is 75. Then at this point where it touches the curve, draw another straight line. You drop downwards from there, like that. You draw this one. Yeah, that is how it's supposed to be. So that is the line. So from 75, you draw straight line to the point where it touches the curve. Then from that point, you draw another straight line. So this is the value. This will be the value. So the value there will be 60.5. To be 60.5. So 60.5. Then the 25th. So 25th is here between 20 and 30. So between 20 and 30. That is the, we draw a straight line, and then at this point, so that is the point. So you draw a straight line to 25, this point straight to the curve. At this point you drop down, so the value will be this will be the value. So that will be the value. Let me read this. This is 32.5, 34, 36.5. That will be 36.5. So you have Q1 and Q3. Now to get the semi-interquartile range, you simply get half the difference. That is a Q3 60.5, subtract 36.5. That is Q1. And these, working out with your calculator, these will give you exactly 12. You get 12. The last one, the pass mark if 70% of the students passed. If 70% of the students passed. So if 70% of the students passed, this is the one that passed, how many failed? So that it means 30% failed. And you're going to use this one to get the pass mark. We use the students who failed in order to get the pass mark. So if 30% of the students failed, how many students failed? So how many students failed? You guess 30%, that is 30 over 100, times the total number of students is 100. So these 30 students. So that is students failed. Sorry, 30 students failed. So the pass mark will be located. So if 30 students failed, then the pass mark will be given by the 31st. So the cutoff of the pass mark will be given by the 31st student. So if you get the mark obtained by the 31st student, that will be the pass mark if 30 students failed. So from 30 first student all the way to 100, those are 70 students. That is 70% who will pass the exam. So we go to the graph where we have the 30, so that is them. So 31st, so 31st position will be somewhere there. So you draw a straight line from 31st up to where it touches the curve, and then straight down, straight down there, straight down, and then you read this value here. So from this point, 31st point where it touches the curve, then straight down, this is the mark. So you read this mark here. This will be, this is a 40.5 plus 1, that will be 41.5. The mark obtained by the 31st student will be 41.5 marks. That will be the pass mark. Let me confirm again. So this is a 40.5, then not yet 42, it is somewhere there between, so that is a 41.5. So that is how you're supposed to solve that question. Question 18. Using a ruler and a pair of compasses only, construct a rhombus PQRS such that PQ is equals to 5.5 centimeters and diagonal PR is equals to 8.4 centimeters. How do you construct these rhombus? Before you construct, you need to understand a very important property of a rhombus, that in a rhombus the diagonals intersect at right angles. The diagonals of a rhombus intersect at right angles. So the way to begin this is first by obtaining PR. You can draw PR. So let me just draw PR. So assuming that is a PR. That is PR, and then now have the point P located somewhere here. So P is there, located there. So I need PR to be 8.4 centimeters. So this is a P. So PR to be 8.4 centimeters. So I'll take a measurement of 8.4 centimeters. I'll use my pair of compass. It is calibrated. So 8.4 centimeters is there. That is 8.4. So with that measurement, I can mark there. So that will be R. So this will be R. So this is 8.4 centimeters. Now from there, I need now to complete from that line. I need to complete and have a rhombus. I will use the property, the diagonals of a rhombus intersect at right angles, and they intersect at the center. They're going to intersect at the center of this line PR. So I will identify the midpoint of PR, and that is very easy since PR is 8.4 centimeters. So the midpoint of that will be located at 4.2. So it will be located at 4.2. So that is where we have 4.8. Then 4.2 will be 4.2 will be there. So let me mark the midpoint of that line. That is where the diagonals are going to intersect. This particular point here, diagonal is going to intersect. So if I have another diagonal passing through there, it should meet that line at this point 90 degrees. So I need to have right angle here. So I will construct a perpendicular line passing through this point here. That is where the other diagonal will be. So how do you do that? Constructing a perpendicular passing through that point. I'll simply start at that point, and then using any suitable radius, I will mark an arc here. I will mark an arc there, and I'll mark another one with the same radius on the other side, like that. Then from there, I can adjust my length using a suitable radius. Then from there, I can stand on this arc here, then mark an arc there, and then another one down there. Don't change the radius, with the same radius to the other arc that you made. Then cut those two arcs. So cut that arc, and then I'll cut this arc as well. Cut that arc as well. So now joining these two, so you can use a ruler to join these. So now you need to join that using a straight line. So that will be the other diagonal. And as you notice, this angle here, this will be 90 degrees. So this one will be 90, 90, 90. That is the property of the rhombus that we have used in order to help us to draw that. So now, having done that, the next step now will be to obtain PQ. Where will Q be? Q will be somewhere here. Then you have P, then Q somewhere here, then R is there, then S will be somewhere there. And since you know the other property of a rhombus, that the opposite sides are equal and parallel. So if I get PQ, it should be equal to SR. So now since PQ is 5.5 centimeters, I'll take a measurement of 5.5. Simply take measurement of 5 centimeters and stand with that measurement at P. So stand with that measurement at P, 5.5. So 5.5 is there. I've taken 5 with a pair of compass, and then I will mark anywhere on that particular line, that bisector. So I will mark, I will cut this line there. So that is where we shall have Q. So Q will be here. That is where we have Q. So mark Q there. And then on the other side, R, remember R, S must be again 5.5. So standing at that point, so let me check. Yeah, that is okay. So that again is that is a measurement of 5.5. So I mark an arc there. That is where we shall have S. So S will be this point. So this is where we shall have S. This is this point. Then from there, you just need to join to complete the rhombus. You simply need to join. So from P, so you join P. Sorry. So join P to Q. So P to Q. Then from Q to R. Then from R to S, and then from S to P, like that. So the rhombus is complete. So P, Q, R, and S is there. It is complete with these measurements here. These will be 5.5 and this is 5.5 centimeters. Now after doing that, we go to the other part. The angle, you're supposed to measure the angle RQP, 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 RQP. So just take a protractor to measure that angle. So this is the angle. Let me mark the angle first. Mark the angle. So the angle you're required to RQP. RQP is this particular angle. We need this angle here. So that is the angle that you need to measure. That is what I'm measuring. So take your protractor and then so now you can see. So ensure you place your protractor very well. So measuring the angle from this side. So from this side you have 10, 20, 30, 40, 50, 60, 90, 100. So this one is around 100, 101. This is 102. It's around 102. Let me confirm whether I've placed this one in the correct way. Yeah, 100, 101, 102, 102. And that angle is 102. So we might get a slightly different answers of these tools that I'm using. So don't worry when you find the very slight difference with mine. There's always an allowance, a slight allowance that is given. So mine is 102 degrees. Then line SQ, we measure line SQ. So SQ, let me take a ruler. So line SQ is so SQ is that line. So this line is 6.5678. That's around 6.8. Around 6.8. That is what I'm getting. 6.8. So you can see, place starting from here all the way to Q. So this 6.5, 0.6, 0.7, 0.8. 6.8. So that one is 6.8 centimeters. Again, an allowance, a slight allowance is always given, plus or minus 0.1 or so on, something like that. So the next one, construct the loci of X, that is part C, such that it is equidistant from point Q and R. Construct the loci of 1 X such that it is equidistant from point Q and R. So that is the perpendicular bisector. So perpendicular bisector loci, meaning we are going to construct the perpendicular bisector of the distance between these two fixed points, that is Q and R. Q and R. So let me go to the diagram. So Q and R are they. So Q and R, you can see the 2 points. So Q is here and R is here. So construct a perpendicular bisector of that. You just use your pair of compasses. So stand at Q, then a suitable radius that is more than half of that line, that. So you mark an arc, that up there, then you mark another one below here. Extend that one a little bit. Then with the same radius, without changing that, go to R, extend it R, and then cut that arc there, and then cut the other one below, like that. So now you can see the point of intersection of the two. So there's this point and there's this point. So you just need to join that using a straight line. So this point, so you can extend that line like that. So that is the line. That is the locus of point X. So the loci of X, so let me indicate it there in the diagram. So this is loci of X. Then the next one is Z, loci of Z, which is equidistant from line PS and PR. Which type of loci is that? That is the angle bisector loci, meaning you're going to bisect the angle between these two lines, PS and PR. The angle between those two, PS and PR. So which angle is that? PS and PR. So you can see, so it is here PS and PR. So this is the angle. Got to get this, the angle here, the angle between here. That is the angle you need to bisect. So to bisect that angle, just take a pair of compasses. It's there, and then standard P, and then just using any suitable radius, mark two arcs, one on that line PR and another one on the other line PS. Then you standard this arc that you made there, then mark an arc above there with the same radius without changing that. Stand on this arc, then cut that arc. Now you can see the point of intersection. The point of intersection of the two arcs is there. So now join from that point to the point of intersection of the arc. So that is what you're supposed to do. And this is the loci of Z. That is the loci of Z. That is the loci of Z. The angle bisector loci. So now after doing that, let's go to the other question. Mark, that is 3, mark the point of intersection of the loci of X and Z as M. So where the two are meeting, the loci X and Z. Where are they meeting? They are meeting at this point. As you can see, they are meeting at this point. So that is the meeting point. So you mark that one as, you're supposed to mark that one as M and measure RMQ. So mark this one as M. And then you measure RMQ. RMQ. So angle RMQ. Angle RMQ. So which is angle RMQ. So you need to complete something there. So from R to M, then I need to draw another line to Q. Need to draw another line to Q. So from M. So from M to Q. Be very careful, these lines are so many. From M to Q. So the angle is here. The angle RMQ. I have to join again, straight line from R to M. R to M. So from R to M. Like that. R to M. So now you can get that angle RMQ. So take your protractor, and then we measure these. So this is the angle. So therefore the angle, I'm measuring the angle from this point, so this way up to this line here. So this is 10, 20, 30, 40, 50, 60, 60. This is 65. And then this is 70. It is around here, 70. So you can see this is the angle, this RMQ. So from 10 all the way to 70. So that angle is 70, approximately 70. So RMQ is 70 degrees. So that is how you're supposed to solve that question. Question 19. A transformation matrix T1 is given there, maps triangle ABC onto triangle A prime B prime C prime. Another transformation matrix T2 is given there, maps triangle A prime B prime C prime onto triangle A double prime B double prime C double prime. The coordinates of point C double prime is 10, 8, and the area of triangle A double prime B double prime C double prime is 15 square units. Part A, 1, determine the coordinates of C. So you're supposed to determine the coordinates of C. That is the object point, and you have the image point. C double prime is given as 10, 8. Now, when you look at this question, you notice that we have successive transformation. We have triangle ABC, which is transformed by T1 into A prime, B prime, C prime, then transformed again by T2 to get A double prime, B double prime, C double prime. Now what we need to get is a single matrix for this successive transformation that would map ABC onto A double prime, B double prime, C double prime. And that single matrix for this successive transformation will be obtained by getting the product of these two matrices. And since this is successive transformation, T1 followed by T2, we are supposed to get the product this way. T2, T1. So for successive transformation, if you have T1 followed by T2, we get the product T2, T1 and not T1, T2. That is for successive transformation. So we need to get these, and this is what is going to help us because our interest is getting that point C, and we already have C double prime. So we go straight to getting that single matrix for successive transformation, T2 multiplied by T1. So T2 is 3, 2. So negative 2, negative 1. Then multiply by T1, 1.5, 0, then 0, 2, like that. And this one, when you multiply these, ensure that you're able to multiply any 2 by 2 matrices. You must understand that concept before you solve this question. So you get 4.5 when you multiply these, negative 4, 3, negative 2, like that. So that is the single matrix of transformation for this successive transformation. So now after getting that, now this is what is going to transform C to C double prime. So indicate it here. So from C to C double prime, this is the matrix that is going to transform that. Now we want to get backwards, since we already have this is a 10, this one is 10, 8. We need now to move from the image to the object. So you're getting the inverse. So to do that, the matrix that transforms C to C double prime, we need to get the inverse of that. The inverse of that matrix, let me correct something here. This is T2, correct this one. This one is T2, T1. T2, T1, like that. So now we need to get the inverse of T2, T1, and that is what is going to take the image back to the object. So we get the inverse of that. So write it as T2, T1, the inverse of that. And to get the inverse of 2 by 2 matrix, we start by getting the determinant first. The determinant of this particular matrix here. This is the matrix. So it will be 4.5 multiplied by negative 2. Then subtract. This is negative 4 times 3. So this one will give negative 9 plus 12. And this will give 3. So after getting the determinant, then this is how we proceed. To get the inverse, 1 divided by 3. Then we interchange these values, and this is how we're supposed to interchange the values. So this will be negative 2, 4, then negative 3, 4.5. Remember, you can see what has happened here. Remember how we get the inverse. So look at the elements in this diagonal, here, and compare with these elements here. So note what has happened. You can see the elements have been interchanged. Then look at the elements in this diagonal. When you're getting the inverse, they have changed the sign. So you need to understand that. So when you multiply these, you get multiply every element in the bracket by a third. That is negative 2 thirds. This will be 4 thirds. This will be negative 1, and this one will be 1.5. So that is the inverse. So that one being the inverse. Now when you multiply, we pre-multiply this one with the coordinates of C double prime to take us back to C. So that is what you're going to do. So we'll take negative 2/3 is negative 1, 4/3 this is 1.5. We multiply that one with this is a 10/8. We should get C, the object. So you multiply that very fast, and when you multiply that, ensure that you remember how to multiply these. I'll do it here. So negative 2/3 multiplied by 10 plus 4/3 multiplied by 8, and then row 2 column 1 you have negative 1 times 10 plus 1.5 times 8. So this will give 4, and this will give 2. So that is a C. So the coordinates of C will therefore be 4, 2. So that is how you're supposed to work out the first part. We go to part 2. Determine the area of triangle ABC. The area of triangle ABC. So you're given the area of A double prime, B double prime, C double prime. So you have ABC, that is what you want to get the area, and then you're given this one as 15 square units. So what are you going to use to get the area of triangle ABC? There is a matrix that has transformed ABC to A double prime, B double prime, C double prime, and that matrix we calculated the determinant of that matrix. That is a T2, T1. We got the determinant as 3. Now what you're going to use in this question is the relationship between area scale factor and the determinant of the matrix of transformation. That matrix that transforms ABC to A double prime, B double prime, C double prime, we shall get the determinant of that matrix, which is already 3. And then remember that the determinant of the matrix of transformation is equal to area scale factor. That is the relationship. So the determinant, which is 3, is equals to, how do you get area scale factor? You get the area of the image, and the image here is A double prime, B double prime, C double prime. The area of object, the object is ABC, that is what you're getting. So this will be 3 is equals to, area of the image is given as 15. Then the object is what you are getting. You can let that to be X. And when you work out this, you get 3x is equals to 15. X is equals to 5 square units. And this 5 represents the area of triangle ABC. That is all for that part. Part B. The coordinates of B and B double prime are x, y, and 6x plus 1, 6x plus 1, 18. I think there's a mistake here. You need to correct this. Not supposed to be 18. It's supposed to be 6. It's supposed to be 6x plus 1, 8. 8. Actually supposed to be 8, not 18. So let me correct this. 6x plus 1, 8. Supposed to be like that. So the coordinates of B and B double prime are given there. Determine the value of y. So already we have the matrix that transforms B to B double prime. The matrix is there, and the matrix is this matrix here, T2, T1. Remember that matrix, T2, T1, that single matrix for successive transformation, T2, T1. So that means if we get that matrix, T2, T1, which we already have, is 4.5, 3, then negative 4, negative 2, and then we multiply that with B. The coordinates for B, x, y, we shall get b double prime. That is 6x plus 1, 8. So that is what we need to, this will help us now to calculate the value of y. Since you know how to multiply this, so when you multiply the left hand side, when you pre-multiply the left hand side, you shall get 4.5x minus 4y is equals to 6x plus 1. You'll form two simultaneous equations. Then we have 3x minus 2y is equals to 8. So you have two simultaneous equations to solve here. You can use any suitable method to solve these. So I'll use elimination. I'll use elimination. So elimination method is what I'm going to use. So you can multiply, you can eliminate x, or you can eliminate y. So let me eliminate y. So the first equation is 4.5x minus 4y is equals to 6x plus 1. So I can reorganize these to have x on one side. And when you do that, you will get, so I want to have x and y to the left hand side. I will have negative 1.5x minus 4y is equals to 1. So what I've done is simply bringing these to the left hand side. So that is equation 1. Then equation 2. Equation 2 is 3x minus 2y is equals to 8. So because I want to eliminate, x, can I eliminate x? So multiply the first equation by 2. That to have negative 3x. So we'll have negative 3x minus 8y is equals to 2. Then the second equation, you just simply multiply that out by 1. So 3x minus 2y is equals to 8. So to eliminate x, have negative 3x and 3x. I will add. So that I have negative 3x plus 3x, I have 0 there. Negative 8y plus negative 2y, I'll get negative 10y. Then 2 plus 8, you get 10. So y will give negative 1. Question 20. 2 points on the surface of the earth are given as A, 30 degrees south, 20 degrees west, and B, 30 degrees south, 80 degrees east. Part A, find the distance along the parallel of latitude in 1 kilometers. Take the radius of the earth to be 6370 kilometers and pi to be 22 divided by 7. So the first thing you need to do is to check whether these two places lie. Of course, they lie on the small circle, the parallel of latitude, and you see that by looking at the positions here. You can see 30 degrees south, both of them are 30 degrees south, but on different longitudes, 20 degrees west and 80 degrees east. Now, how do you get distance in kilometers along a parallel of latitude? This is how we get the distance. So distance is given by theta over 360 multiplied by 2 pi r cosine of alpha, where theta is the longitude difference, that is the longitude difference between the two places, and then alpha is the latitude angle where the two places lie. So using that, now we can get the distance. So distance is equals to the longitude difference. How do you get the longitude difference? One place is 20 degrees west, the other one is 80 degrees east. So we add 20 plus 80. So you get that one to be 100 degrees. So 100 degrees divided by 360 multiplied by 2 multiplied by pi multiply by r, the radius of the earth, 6370, multiply by cosine of the latitude. The latitude is 30 degrees. They lie on the latitude 30 degrees. So you just need to use the calculator to work out these. And this will give 9632.13 kilometers. We go to the second part, the same distance in nautical miles. So how do we get this distance again in nautical mile? Distance along the parallel of latitude in nautical miles. We get it by taking 60 theta multiplied by cosine of alpha. Of course, theta remains to be the longitude difference. Alpha is the latitude angle. So this will give 60 multiplied by the longitude difference, which is 100. Then cosine of the latitude, which is 30 degrees. This will give, use a calculator for this, to give 5196.15 nautical miles. Then part B, determine the local time at B when it is 1:45 p.m. at A. Determine the local time at B when it is 1:45 p.m. at A. When you're calculating time, we use the longitudes. So what is the longitude at B? The longitude at B is 80 degrees east. Then the longitude at A, is 20 degrees west. And you're given the time when it is 1:45 at A, 1:45. So this one is 1:45 p.m. Now, after identifying the longitudes, now one important thing that you need to know is that places that are to the east of the prime meridian, one important thing that you need to know when it comes to longitudes and time is that places to the east of the prime meridian are always ahead of time. So in this case, place B will be ahead of time because it is to the east. You can see that is 80 degrees east. Then A is west. So the first thing, you get the longitude difference between the two places. One is east, the other one is west. So the longitude difference, you get it by taking 80 and add 20. So it will get, you get 100 degrees. Then for every 1 degree, there is always a difference of 4 minutes. So what about these 100 degrees? So this will give 400 minutes. 400 minutes is equivalent to 6 hours and 40 minutes. So that means between these two places, A and B, there's a time difference of 6 hours and 40 minutes between A and B. And since B will be ahead of time because it is to the east, then it means that it will be ahead of time by 6 hours and 40 minutes. So to get time at B, so time at B will be given by, you take 1:45 p.m. and then you add 6 hours and 40 minutes. So this will give 8:25 p.m. Part C, a plane left A and flew northwards, covering 5,400 nautical miles in 7 hours, 15 minutes to another point C. Find the position of C. Find the position of C. Now, you need to identify that distance. The plane left A and flew northwards. So that means it was flying along the same longitude, distance along the same longitude from A northwards. That is distance along the Great Circle. And you're given that distance in terms of nautical miles. So how do you get distance along the Great Circle? Because this plane was moving from A northwards, that is distance along the meridian or the longitude, which is distance along the Great Circle. We need to understand that. And to get that distance in nautical miles, distance along the grid circle in nautical miles given by 60 multiplied by theta. Now it is on the same longitude, so it will be on different, the distance that you're going to get there, the difference, this difference, that is theta, will be the latitude difference. Why? Because A is 20 degrees west, so it is moving northwards on the same longitude, 20 degrees west. So that means it will be moving to a different latitude. So we have to get the latitude difference. Theta will represent latitude difference, and that distance is what you're getting as for 5400. So therefore the latitude difference will be given by 90 degrees. So this is the latitude difference. That will be the latitude difference. So that will help us now to get the latitude of C. And the latitude of C, since it is moving northwards, we are going to look at A, look at the position of A. A is 30 degrees south, so 30 degrees south. So the latitude of A is 30 degrees south, and you have the latitude difference. So to get the latitude of C, we shall get the latitude difference, which is 90, and then we subtract 30 degrees, the latitude of A. This will give 60 degrees, and it is moving northwards, so it will be to the north. So now the position of C is supposed to be written in terms of the latitude 60 degrees north, and on the same longitude 20 degrees west. So that is how you're supposed to work out that part. Then we go to part 2, the speed of the plane in kilometers per hour. Speed of the plane. So how do we get the speed in kilometers per hour? Of course, the speed is obtained by getting the distance over time taken. We have the time is given. The time is 7 hours and 15 minutes. And is given as 7 hours 15 minutes. Then the distance is given in nautical miles, 5400 nautical miles. But we need these in kilometers per hour. So what are we going to do? We shall convert 54 nautical miles to kilometers, and then we work with the distance in kilometers and time in hours. So to do that, we use 1 nautical mile is given as 1.853 kilometers. So what about 5400 nautical miles? So this will be 5400 times 1.853. This will give the calculator for this 10,006.2 kilometers. 0.2 kilometers. Now, having the distance in kilometers, now we need to get the time in hours. So 7 hours and 15 minutes. So 7 hours and 15 minutes would be 7 hours, and then 15 minutes, convert them to hours. So 15 divided by 60. So this will be 7 and quarter hours. 7 and a quarter hours, which is the same as 29 divided by 4 hours. So now speed is given by distance 10,006.2 kilometers, then divided by 29 divided by 4 hours. So when you divide these, you'll get 1380.17 kilometers per hour, and that is how you're supposed to solve that question. Question 21. The figure below shows a cuboid PQRSTUVW where WV is equals to 4 centimeters, VU is equals to 6 centimeters, and UR is equals to 5 centimeters. So let me indicate the measurements. We have WV is 4, and then VU is 6, UR is 5, and you're supposed to, let's go to the questions now. Calculate the length of the projection of VS. The length of the projection of VS. The length of the projection of VS. So what is the projection of VS on this plane? WVUT. WVUT is the base. So the projection of VS will be VT. Be VT. So let me, that is VS. So that is VS. So we have its projection is VT. So we therefore need to get VT. How do we get VT? We shall use triangle VUT. The base is a rectangle. This is a cuboid. And these angles are all right angles. So VUT is a right angle. And the sides are given there. We have 6 and 4. So VT will therefore be the hypotenuse. We get it by taking 6 squared plus 4 squared. Simple as that. And these will give 7.211 centimeters. That is the projection of VS. Then part 2, the angle between PQUT, the angle between PQUT, so is that PQU is PQUT, you can see that, and WVUT, that is the base. So I'll draw that. PQUT. So look at that plane. PQUT, and then the base. You're supposed to get the angle between there. So when you keenly look at this, the angle that is between, allow me to draw many lines here to explain these. So if you draw line, perpendicular line there to the line of intersection of the two planes, the angle that you need to get is this particular angle that is here. There's an angle that is here. This angle, which is the same angle with what we have there. So it is this angle or this angle that is here. So there's a triangle that will be formed here. That is a triangle. So look at this triangle that is formed there. So this triangle here. And that triangle is not so much different from what we have here, because you have this side is 6 and this one will be 5. So you can either use this angle here. So the triangle, I'm going to extract it here. So this side will be 6 and this will be 5. The required angle will be here. So how do you get that angle? You can use tangent. So tangent of that angle is equals to opposite side over the adjacent, which will give, theta will give the tan inverse of 5 divided by 6, which will give 39.81 degrees. Then you go to part 3, the angle between plane QVTS. I'll have to rub these. That you can see that plane. QVTS. VTS. So that is the plane. So that is a plane QVTS, and W, not W, but TSRU, TSRU, TSRU. TSRU. So TSRU is here. TSRU. So look at those two planes. The angle between the two is actually this angle that is here. That is the angle. That is the angle between those two planes. QVTS and TSRU. So how do you get that angle? Remember we said you have this base here, and we have this as 6 and you have this one as 4. That is the right angle, so you're going to use that triangle there. So let me extract it. Yeah, so we shall have so this is 6 and 4, be 6, and this one will be 4. So the angle we require is that, the angle that I've indicated there. So how do you get that angle? Again, you're going to use tangent. Tan of theta is equals to opposite divided by adjacent. So theta will be the tan inverse of 6 divided by 4. And this will give the angle as 56.31. We go to the next question. Points A and B are the midpoints of line PW and QV respectively. Find the angle between ABUT, ABUT, ABUT. I'll rub this one again. ABUT. So ABUT. That is a plane, ABUT, and WVUT, WVUT, WUVT. So that is the base. The base. So WVUT is here. WVUT. So the base. So the angle between those two planes, you can get it by, if you draw a perpendicular line to that line of intersection of the two planes, and then another one like that, you'll have there is 90 degrees. So it is this particular angle here. That is the angle, and it is the same angle with what we have there. That is the angle between the two planes. And the only difference will be, because A and B are the midpoints, and this height is 5, so this will be 2.5. Then this one will be 2.5. Then this will be 6, and then that one will be 6. So if we extract that triangle, this is what you're going to have. This is 6 and 2.5. So this will be 6, and this one will be 2.5. That is the angle. So just look at it again. See that? And now to get the angle again, you have to use tangent. Tangent of theta is equals to 2.5 opposite divided by adjacent. So theta will be given by the tan inverse of 2.5 divided by 6. And these will give 22.62 degrees. And that is how you're supposed to solve that question. Question 22. The velocity Vm meters per second of a particle at any given time t is given by the equation v is equals to t squared minus 4t plus 5. Part A, complete the table below for the equation v is equals to t squared minus 4t plus 5, 2 marks. The table is there for t and v values. You're supposed to complete it and get 2 marks. This is a straightforward, since you just need to use the calculator using this equation to fill. So you simply need to take the values of t and substitute in this equation of v. So for example, the first one, what will be v when t is equals to 3? So you just need to take this. So v is equals to, you just substitute, put this on your calculator. So t squared, so t is 3, so that will be 3 squared minus 4. Then t is 3, then plus 5. That is what you just need to feed in the calculator. Just substituting the values of t in this equation and you get the value v. So that one will give 2. So that will give 2 here. So that one you have 2. I'll fill all the others since the same procedure, the one that you're supposed to do, just using a calculator, being very careful when you're using that. The next one is when t is equals to 3.5, v will be 3.25. When t is equals to 5.5, v will be 13.25. When t is equals to 6, v is equals to 17. When t is equals to 6.5, v will be 21.25. When t is equals to 7, v will be 26. When t is equals to 8, v will be 37. By just doing that, being very keen, when using the calculator, you get 2 marks. Those are 2 marks for that. Part B, estimate the area enclosed by the curve V, t squared minus 4t plus 5, x-axis, lines x is equals to 2. So these will be the lines t is equals to 2. This t is equals to not x. So just replace this on, slight error there. Lines t is equals to 2 and t is equals to 8 using the trapezoidal rule with 12 strips. So you're supposed to get the area between t is equals to 2 and 8. So it is between there and there. And you're using the trapezoidal rule with the 12 strips. Already, the range that is given from 2 to 8, those are 12 strips. We have the first strip here from 2 to 2.5. That is the first strip. The second strip is there. The third is there. The fourth, the fifth, the sixth, 7, 8, 9, 10, 11, and 12. Those are the 12 strips. We count the strips from 2 to 2.5, that is one strip. From 2.5 to 3, that is another strip, and so on. Now, first thing is to write the trapezoidal rule. Trapezoidal rule, we get the area by using these, approximate the area using the trapezoidal rule, that is a half. A is equals to a half height. This is the trapezoidal rule. Then y0 plus yn plus twice y1 plus y2 plus y3 and going on up to yn. So that is the trapezoidal rule, whereby y0, we are going to start from this particular point. So y0 will be here. Then all the way yn will be the last one. So from here you have y1, y2, continue like that, y3. I'm taking the values of, now these values of v are the ones that I'm denoting as y0, y1, and so on. So like, you look at that row where you have v1 is y0, then the last one there is yn. So from there you have y1, y2, y3, y4, y5, y6, y7, all the way y8, y9, y10, y11, up to that. So that is what we need to use. So we just need to substitute these values. So this will give the area will be height of each strip from 2 to 2.5. What is that height? From 2.5 to 3. You can see there's a difference of interval 0.5. So that is 0.5. Height is 0.5. Then y0, the first one in that row where you have v, that is what you're reading, 1 plus the last one there is 37, that is yn. Then plus twice all the middles, all the middle values there. So we have 1.25 plus 2 plus 3.25 plus 5 plus 7.25 plus 10 plus 13.25 plus 17 plus 21.25 plus 26 plus 31.25, like that. So this will give a half times 0.5, that will be 0.25. Then this will be 38. Then add everything else that is there. So you get, just put this one in the calculator and get the sum and multiply. So 2 into brackets, then get the sum. Just using your calculator, just press 2 and then open the brackets, then add everything there, 1.25 plus 2 plus 3.25, all the way up to that 1.25. And that one will give, if we do it correctly, that will give 275. 275. That is what you get. Then this will give 0.25 multiplied by 38 plus 275, that will give 313. So this will give, when you multiply 0.25 times 313, this will give 78.25 square units. Simple as that. So that is how you estimate the area using the trapezoidal rule with 12 strips. Part C, find the exact area using integration. Integration. So supposed to integrate from, get the area by integration, integrate from t is equals to 2, t is equals to 8, then the function is t squared minus 4t plus 5, and you are integrating this one with respect to t. So integrate t squared, you get t cubed divided by 3 minus 4t. Integrate that, you will get 4t squared divided by 2, that will give 2t squared plus 5. Integrate 5, you get 5t plus the constant of integration 2 to 8. So from here, you start by substituting 8 in t. So you'll have 8 cubed divided by 3 minus 2, 8 squared plus 5, 8. Then you can drop c because it will be subtracted and you get 0. You can drop c at this stage. Now substitute 2. So that will be 2 cubed divided by 3 minus 2, 2 squared plus 5, 2 like that. Now you can use a calculator to work out these. 8 cubed divided by 3, that will give 512 divided by 3, and this one will be 128, then plus 40, subtract, this will be 8 over 3 minus 8 plus 10. So working out 512 divided by 3 minus 128 plus 40, that will give 248 divided by 3. Then 8 over 3 minus 8 plus 10, that will give 14 over 3. So when you subtract these using a calculator, you get 78 square units. That is the exact area by integration. The last one, find the percentage error using the trapezoidal rule. So percentage error, so look at the exact area is 78 square units. Using the trapezoidal rule, 78.25. What is the error? So to get the percentage error, you get error, the absolute of error, divided by the actual area, multiplied by 100%. So the actual, now to get the error, look at the actual. The actual is, so the actual area is given there, it is 78. It is 78. Then subtract the area by trapezoidal rule, 78.25. You get the absolute of that. Then divided by the actual area. The area by integration is the actual area. And then multiply by 100. So when you subtract these, you'll get, you are considering the absolute. So 78 minus 78.25, ignore the negative, so you get 0.25 divided by 78 times 100%. This will give 0.3205% as the percentage error. Question 23. A particle moves along a path OR such that t seconds after leaving point O, its velocity v meters per second is given by v is equals to 4t squared minus kt plus 9, where k is a constant. The particle is momentarily at rest at r when the time t is equals to 1.5 seconds. Determine A, the value of k. So you start with that one, 2 marks. How do you get the value of k and what is going to help us? Now what is going to help us here is this information that you're given here, that the particle is momentarily at rest at r when the time is 1.5 seconds. So what do you know in terms of velocity when a body is at rest? So when a body is at rest, like in this case, the particle is at rest at r, velocity at that point is equals to 0. When the body is at rest, velocity is equals to 0. So we'll take this expression for velocity and equate it to 0. So velocity is given by 4 t squared minus kt plus 9. So at rest it will be 0. 0 is equals to 4t squared minus kt plus 9. Then another thing, we are given the time it is at rest when t is equals to 1.5 seconds. So what we need to do is simply just to substitute t is equals to 1.5 seconds in order to get the value of k. So 0 is equals to 4. T is 1.5, so this would be 1.5 squared minus k. T is 1.5, then plus 9. So this will give 4.4 times 1.5 squared that will give 9, then minus 1.5k plus 9. So find the value of k here. So 1.5k is equals to 18, and k will be given by 12. So that is the value of k. Part B, the distance from O to R. The distance from O to R. So how do you get the distance? Now we have the velocity. So if you're given the velocity, to get the distance, which I'm going to show it by S is the displacement of the distance, we get it by integrating velocity. So when you integrate velocity, we get distance. So since we have the full expression for velocity, we are going to integrate these. And now the distance from O to R, we're going to use the time. So we're going to use the time taken from O to R, and the time taken from O to R is 1.5 seconds. So from 0, it started from 0 seconds to 1.5. So that is the time taken. So we integrate these very fast. So we get the integral from 0 to 1.5 of the velocity. The expression for velocity is 4t squared minus k is 12. We got that as 12 plus t, and integrating this one with respect to t. So when we integrate 4t squared, we shall get 4t cubed divided by 3 minus, we integrate negative 12t squared, that will give 6t squared plus 9t, then plus the constant of the integration from 0 to 1.5. So from there now we substitute 1.5 in this expression there. So we have 4/3. T is 1.5 cubed minus 6, 1.5 squared plus 9t. T is 1.5. And then when you substitute 0, of course c will be eliminated. You're going to subtract c. Now you need to substitute 0 where we have t, and when you do that, you only have you'll have 0. So that will not make any difference. So what you need to work on is simply these, whatever we have here. So use your calculator to work out these. Use a calculator to work out these. So 4/3, 1.5 cubed, this will give 4.5. 6 times 1.5 squared, that will give 13.5. Then plus 9 times 1.5, that will give 13.5. When you work out these, you'll get 4.5 meters. That is the displacement. That is the distance from O to R. We go to the next one, part C. The distance it covered in the 3rd second. The distance it covered in the 3rd second. So in the 3rd second means it is from 2 to 3 seconds. So we are going again to get the distance by integrating a velocity from 2 to 3 seconds. So 4t squared minus 12t, this velocity, plus 9 with respect to t. So we have already done this. So this will give 4/3 t cubed minus 6t squared plus 9t plus a constant of integration. So from 2 to 3. So from there we substitute 3. Substituting 3, these are you going to get 4/3, then 3 cubed minus 6 3 squared plus 9 3 Then you can omit the constant of integration, since it will get subtracted and you get 0. So that is when you substitute 3. Then subtract now. Now substitute 2. Substitute 2. So you have 4 thirds. 4 thirds, 2 cubed minus 6. 2 squared plus 9. Substitute 2 there. Like that. Use a calculator to work out these. Now you have 4 thirds multiplied by 3 cubed, you get 36. Subtract these will give 54 plus 27. And then subtract. Now these will give 4 thirds multiplied by 2 cubed, these will give 32 over 3. Minus, these will give 24 plus 18, like that. So for doing that, the whole of these will give 36 minus 54 plus 27, that will give 9. And then 32 over 3 minus 24 plus 18, that will give 4 and 2 thirds. So this one will give 4 and 2 thirds. So when you subtract 9 minus 4 and 2 thirds, you get 4 and a third meters as the solution. We got part D, the particle's acceleration when t is equals to 1 second. How do you get acceleration? Acceleration is what you're supposed to get. So we get acceleration when we differentiate velocity. So acceleration will be given by dv dt. That is when we differentiate velocity. So therefore, remember the expression for velocity. Velocity is up there. So 40 squared minus 12t plus 9. So now when you differentiate these, we get acceleration dv over dt. That is what is going to give velocity. Now that is what is going to give acceleration. So this one is 40 squared. Differentiate that, you get 8t minus 12. So acceleration is equals to 8t subtract 12. Now what will be the acceleration when t is equals to 1? So at t is equals to 1, you just need to substitute. A is equals to 8, t is 1, subtract 12. This will give negative 4 meters per second squared. Question 24. Part A. Complete the table below for the functions y is equals to 3 sine 2x plus 30 and y is equals to cosine of 2x, giving your values correct to 2 decimal places to max. So we start with that. Now to work out that, you only need to be very keen. Use your calculator to do this. Just use the calculator properly and fill in all the values using the functions given correct to 2 decimal places. Just demonstrate using one of them, because that is something that you're supposed to use a calculator to do, which is quite easy. Now for example, the first one here, cosine of 2x, we need to fill this part. Cosine of 2x, how are you supposed to do it? So I have a table that I've already refilled. I'd like you to look at it. It is there. So look at that. So this is what you're supposed to do to obtain these values that I've filled in red. So y is equals to, I want to fill these 1 to get these 1.00. You are using y is equals to cos 2x. So cosine of 2, then what is x? X is 0. So you're multiplying that one by 0. Like that. X is 0 degrees. So this one you have to get the cosine of 0. Cos 2 times 0, that will be cosine of 0, which is 1. Then for 15 degrees, how do you get this value, for example? So this is what you're supposed to key in your calculator. you're supposed to key in 3 sine, you just write the way it is, then put the brackets, then 2 times x, 2 times x, 2x, so x is 15 degrees, so 2 times 15 degrees will be 30 degrees plus 30 degrees. So this will give 3 sine of 60. So when you just feed in this information the way I'm putting it in the calculator and press OK or is equal sign, you'll get 2.6, and that is what you're supposed to do. So for all the others, that is the same procedure that you're supposed to follow in order to fill all the others. So this one is negative, this one is negative, and so on, and ensure that all of them are filled correct to 2 decimal places. Once you've done that correctly using your calculator, you'll be able to get the 2 marks. If you're not careful with the way you fill this table, you might end up having problems when it comes to plotting the graph. So anytime you experience graphs that, like this one is a trigonometric graph, you expect this one to be a wave, you find is giving a funny kind of a curve, just go back to the table and confirm your values. Now we go to part B. Using the scale, you're given the scale horizontal axis, 1 centimeter represents 15 degrees, and the vertical axis, 1 centimeter represents 1 unit. You should strictly use the scale that is given. Horizontal, that is the x-axis, use this scale. If you don't use this scale, you lose the mark for the scale. Then on vertical axis, 1 centimeter represents 1 unit. So all you need to do is simply to use the values that are here. The scale is already given, and you are required to use the values you're given there. So the y-axis, 1 centimeter to represent 1 unit. So we have the y-axis, you can see the scale 1, 2, 3. Then the x-axis, 1 centimeter represents 15 degrees. So plot all the values. All the values, you can see they are plotted there. Plot all the values. Plot everything correctly. And then make sure you join all these values using a smooth curve. You may not have exactly the curve that you're seeing there, because yours will be handwritten, but at least you're supposed to ensure that it is smooth. So plot all the points. We indicated all the points there, and then after doing that, make sure you write the equation of the function against that curve. So you can see we've done that. The curve in red is y is equals to 3 sine 2x plus 30. The other one is y is equals to cosine of 2x. So this is where you have all the marks, and you get 5 marks for these. So for the scale, you'll get 1. For the first curve, you have a smooth curve, you get a mark. Then the plotting correctly, you get a mark. Then for the second, you get the curve, smooth curve, you get a mark. Then plotting again, you get a mark. And then overall scale, using the scale that is given, you get 1 mark. So you can see these are 2 marks, these are 2 marks, this is 1 mark. So that is how you get the 5 marks. So after doing that, we can proceed to the other question. We proceed to the other question, that is a part C. Using the graph in part B above, 1, determine the period of y is equals to 3 sine 2x plus 30. How do you get the period? The period will be given by 360 divided by 2. Remember, if you have the equation y is equals to a sine bx plus or minus theta, then period period is given by 360 divided by b. In this case, b is 2. B is 2. So 360 divided by 2, you get 180. Then the last part is find the value of x for which 3 sine 2x plus 30 is equals to cosine of 2x. So what do you check? You check the point of intersection of the two curves. That is what gives you the solution. So the point of intersection of the two, check where the two curves are intersecting. They're intersecting at this point and at this point. So you read the angle. Like for this part that is here, the angle will be 84.5, the angle that is here. So if you just draw a straight line here, so from here, just draw a straight line there. So you read this angle that is here, this angle. So this point of intersection, read this angle, that will be 84. Then the other one again, you do the same. So they're intersecting at this point. So you drop downwards there. So again, these will give you the angle. We draw this one properly. So this is what is going to give you the angle. So the angle that is be at this point here, and that angle will be 174.6. If you read that one carefully, that is what you're going to get, the angle that is here. So you check the points of intersections and then you read this angle here. That is how you're supposed to work it out. Okay, slight allowance is always given, plus or minus 1 degree. You can allow that. So any answer that is within this range will give you 2 marks for that. So that is how you're supposed to solve that question on trigonometric curves.